This is Josh White with JW Math Tutoring. Today's video is going to cover 10 problems from the Digital SAT August 2024 test. So let's go ahead and get started.
But life is a dream the calculus could never predict.
Just before I begin going through these 10 problems from the August 2024 Digital SAT Math section, just want to talk about one thing, and that is these are problems, that I basically kind of put together from, comments that were posted online. So a lot of these problems you'll see, if you actually encounter them on a test, they would be multiple choice. But here I'm solving a lot of them as free response questions. So just keep that in mind. Some of these, do like people to remember the kind of the full problem and the various answer choices with them. So I've included those wherever possible. Um, but a lot of these, like I said, could be multiple choice. And of course, if they were multiple choice, then there might be other ways to solve them rather than just what I'm demonstrating here. Okay, so when I'm solving them as a free response question, just keep in mind there could be other ways to solve these if you do have the answer choices provided to you from the beginning. Okay, so with that being said, this video, this is basically going to be part one. This is going to cover 10 questions, and then of course there will also be part two and part three, which will each have 10 more questions as well, for a total of 30 questions. All right, first question here. Sorry, one other thing. In the description, if you haven't seen it already, there's a link to a PDF file which has these questions that you can work out ahead of time, and then check your answers in this video. So now, getting started with question number one. So we have this, basically the shirt, which is has a wholesale price of $6, and then to get the actual regular price that it's sold for, you take 260% of that, and then after that, you go ahead and you discount it 80% off to get the what you call the discounted price, whatever at the end of the season. So this question is asking for the discounted price. So all we have to do is a couple calculations with percentages here. We can just take the $6, which is the wholesale price, and then to get the regular price, we can do 260% of that, which means multiply it by 2.6 or 2.60, since 260% converted to a decimal is 2.60. If you do that, you will get the regular price being $15.60. Then you have to subtract 80% of that. So we're just going to take 0.80, multiply that by the 1560 to get the amount of the discount we're taking off. That is just $12.48. Then you can subtract those two, and the answer would come out to be $3.12. So not sure if this would be a multiple choice or they would actually want you to enter 3.12 if it was for response, but this is just basically how you can solve it. All right, the next question deals with a pyramid, specifically a pyramid with a square base. So I can do my best to get a picture here. So it's going to look something like this. They give you the total surface area, okay? And the total, I'm just going to call it TSA, total surface area is 19,200. That's the area of the four triangular faces and the base, the square at the bottom. They also give you the combined surface area of the lateral faces. So by that, I mean that's the area of the four triangles, here. This front, left, right, and then you can't really see it here, but back, those four faces. So whatever, I'll call that the lateral area, and that's 9984. They want to know the height of this pyramid. So for this problem, it's complicated or it's difficult because you have to go through a bunch of different steps, but the actual steps themselves are not that difficult. It's being able to put all of them together, because it's like going to be 5 or 6 different steps you'll see to get the final answer. So the first thing we need to do is we subtract these two numbers, and that will give us just the area of the base. It's also usually in the formula for volume of a pyramid, it's abbreviated B. Okay. Specifically, this base is a square. So if you go ahead and subtract that, you should get 9216. Let me just actually do the calculations as we go through, just to confirm I'm reading my handwriting correctly. All right, yep, 9216. All right, so now we can then take the square root of that number, and that will tell us the length of each side of the base, because the base is a square. So we know its area is just, this side squared times this side times this side, or basically say like x squared. So if we take the square root of that, it comes out to 96. So each edge of the base is equal to 96. So 96, 96. All right. Now we have to do to find the height is set up some triangles. Actually, we're going to set up one triangle, but we need a measurement first. We have to figure out one side of that triangle first. Technically, it's going to be the slant height. So here's kind of what's going on. So you have the height coming down here. Okay, it's perpendicular to the base. And so you're going to set up a right triangle like this. Now, this bottom side here this is technically in the middle. Ignore my, poor drawing. So that means this side of the triangle is going to be 48. This height here is just h. That's what we're trying to find. But we don't know the hypotenuse. We need to know a value for the hypotenuse. Then we can use Pythagorean theorem to find the value of h. So the hypotenuse of this triangle is technically, called the slant height of the pyramid. And just to give you a visual idea of what's going on, this is one of the faces, okay, of the triangular pyramid. So you have this down here at 96, and then you have this perpendicular line coming down here. This is the height of this triangle, but it's this L. It's the slant height of the pyramid. In other words, it's the hypotenuse that we need to find the value of. So the way we do that is we notice, okay, the total lateral area was 9984. We divide that by 4. That comes out to 2496. That is the area of one triangular face, or you could say the area just of one triangle. All right. Now we know that 2496 is equal to 1/2 the base times the height. The base is 96. That's the edge of the square. That's the base. The height, that's what we don't know. That's the L. That is the slant height of the overall pyramid. In other words, that's what we're solving for. That's the value we need, which is going to allow us to eventually solve for the height of the pyramid. So I would just make this 48, and then if we go ahead and solve this out, you should get, just looking at my notes here, 52 for L, or the slant height. And I'll just go back to confirm here. Let's just do the calculations real quick. 9984 divided by 4 times 4. 9, typed it wrong. 9984, there we go. 2496, okay, and then that 2496 is equal to 48 times L, so we divide that by 48. Okay, we get 52. Slant height's 52. Now looking back at this picture, and I'll just enlarge it so it's a little easier to see, what you have going on is you have the height of the pyramid here, you have this side which is 48, it is half of one of the sides of the square base, and you have the hypotenuse which is 52. Now you can just use Pythagorean theorem. It's basically going to be h squared plus 48 squared equals 52 squared. I won't bother to write out, all the numbers for the calculations. I will just tell you that the answer that you get for h for the height turns out to be 20. And I'll just show you that we can confirm that in Desmos, because we're basically looking for the square root of 52 squared minus 48 squared. Okay, yep, it's 20. So the height of this pyramid is 20. And that would be your final answer. All right, next up, here we have two equations. They've got a bunch of different letters in them, A's and B's and everything, and they're asking for the value of 1 over n here. So Easiest way that I see to solve this is to notice if you take the first equation and you basically divide both sides by 3, a over b is equal to 3.5 over 3. You could also technically turn it into 1.167, or you could also turn it into, let's see, a fraction. It's actually good practice. So now I just click this. There we go, 7 over 6. So whichever form you want to use is fine. Just make sure I wouldn't use this middle one because you want the exact value. You don't want the rounded value. So now go to the second equation and here you see you have a over b. So it's like if you separate that out, now you can replace this with what it's equal to. So let's put in the 7 over 6, it's 1 over n, and then 17.5. And then to solve for 1 over n, all we have to do is get rid of the 7, 6. So we're just going to cancel out. We're just going to multiply by 6 over 7. So just go to Desmos, punch this in. It should turn out to be 15, but again, I'll just confirm. Slide this over. So we're looking at, here we got 7 over 6. We can, no, we want the reciprocal of that. So 17.5 times 6 over 7. Yep, right there. So the right side simplifies completely to 15. The left side has the 1 over n that we're looking for. So 1 over n would be equal to 15. That would be your final answer. All right, next up we have a question that dealt with basically a cube, or think of it as a box, and it had an open lid, so there's no lid on top, and they gave you the side length in centimeters. But here's the trick. They want the total surface area in square meters, not square centimeters. So there's a unit conversion going on here. So you could do this two ways. The way that I would probably do it is I would take 89 centimeters and I would convert that to meters by noting that 1 meter is 100 centimeters, basically dividing 89 by 100. So in other words, each side is 0.89 meters. So 0.89, 0.89, 0.89. And now we can just find the total surface area. Basically, each face is just going to be 0.89 times itself, because each face is a square. And then since there's 5 of them, because there's no lid, so it's open. It's not times 6, it's times 5. So really your calculation here is just 5 times 0.89 squared, and that should work out to 3.9605. Again, just double check that. Yep, 3.9605. So that's the total area in square meters. Total surface area for this situation in square meters. Now, a couple things. If this was a free response, what you would technically write in is 3.960, five total spaces, like one for the decimal and 4 numbers, or 3.961. If you could either truncate it, that's the first one, or you could round it. Okay, either would be acceptable. But it's possible this is a multiple choice problem, in which case they've just listed out the full number. All right, that's one method to solve it. Another alternate approach you could take is you could find the total surface area in square centimeters, which would be 5 times 89 squared. And when you do that, let me see here. It's some pretty large number. And then that number, so let's just get rid of this. Oh yeah, it's just going to be 39,605. Okay, so this is the total area in square centimeters, but then you have to convert square centimeters to square meters. So technically, you have to divide by 100 twice. Or if you use factor label, it's like 100 centimeters, 1 meter, and then you have to do it a second time. 100 centimeters, 1 meter. So basically, you take that number, you divide it by 100 squared, and notice we get the same answer, 3.9605. Okay, so That's how you could get it, basically doing the conversion after you calculate the area. So you can do the conversion beforehand, centimeters to meters, or you can do it afterwards. Doesn't matter, but you do have to just, make sure you do it properly for whichever approach you take. Next up is a word problem. So here you have two positive numbers. We know that they're added, sorry, not added, multiplied, because their product is equal to 385. And we also know that, say, the second number, which I'm going to call y, is 13 greater than, more than, twice the first number. So you just set up a system of two equations, and then you can go ahead and solve this, for x or y. So I'll just show the traditional method first, which would be just to take this and plug it in. And then I'll show the Desmos method after that. So we get 2x squared plus 13x minus 385 equals 0. I mean, this you probably don't know the factors of it. So even if you got to this point by hand, I would still probably go to Desmos because it's going to factor as 2x plus 35 and x minus 11. So you just set each of these equal to 0. You get two answers. Positive 11, negative 17.5. Okay, the negative value obviously doesn't work. Tells us it's a positive number right here. So if they ask for, it says here, what is the value of one of the numbers? Well, 11 is one of them. Or if you plug 11 in for x, 2 times 11 is 22, plus 13, 35. So either of these would be acceptable correct answers, either 11 or 35. Now, just to show you, if we go to Desmos, it's going to be so much quicker to solve this just by graphing these two things and looking for the intersection. All right, so let's zoom out. Okay, so notice there's 2 points where they intersect, right? Right here, obviously these are negative numbers. We don't want that. Right here. So what are our two possible numbers? Well, 11 is one of them, 35 is another one. So much quicker just to, once you get the equations, just go straight to Desmos and do it there. All right, next up, we have a problem that dealt with basically an exponential function, okay? And they give you this equation, and they basically want you to find the value of b. So this equation might look confusing, and that's fine, but really all that's going on here is, if you notice, if you subtract like this 0.86 times f of n minus 1 over to the other side, what you have is basically there's like an imaginary 1 here, okay, in front of this f of n minus 1, and then you have the minus 0.86 f of n minus 1, and that's equal to the, say, f of n value. So notice you can technically now subtract 1 of this quantity minus 0.86 of it, and you get 0.14 f of n minus 1 equals f of n. So here's what's going on. Here's what that means. It's like if you think about a chart, right? Say this is like the n minus 1 thing, and this is the n like column or whatever. If the f of n minus 1 value is, let's say, 10, if you replace this with a 10, okay, the y value. Well, to get the f of n value, you just multiply 10 times 0.14. Okay, so that means this would be 1.4. So this is just a decreasing exponential function. In other words, to get your current y value that you're calculating, you take like the previous y value, the y value that corresponds to 1 prior to whatever x value you're looking at, and you multiply it by 0.14. That means b is 0.14. And that's the, basically that's the answer, and that's it. Now, an alternate way you could do this, and this is a bit more theoretical, but I'll just show you because this is actually like kind of the first way that I did it, is I just plugged all this stuff in for the f of x and everything, like in all these expressions, and then I solved actually for b. So what I mean by that is f of n minus 1 means I have a, b, and then for x I'm plugging in n minus 1. And then f of n means I have a, b to the n. And then I've got 0.86 times a, b to the n minus 1. So then what I did is went through the same process. Let me just look at my notes here. Yeah, I went through the same process. I subtracted this over to the other side, and I got 0.14 AB n minus 1 equals AB to the n. Notice, first of all, you can divide by a's, they will cancel out. Okay? Just a constant, it's not 0, and so therefore we can just get rid of that. Then, what you can technically do is, if you divide by b to the n minus 1, you get 0.14, and on the right, you subtract the exponents, n minus 1, n minus n plus 1, n minus n 0 plus 1. So you're just left with b to the first, and you get b equals 0.14. So that's just an alternate way to solve it as well and get, the same answer. Next up, we have a fairly complicated question where you're given like a quadratic. Basically, it's a quadratic, and you've got some parentheses or whatever that need to be multiplied out, and you also have like essentially an equivalent expression that you're trying to make it equal to. But like, notice they have these like a, b, and c over 6 things, whatever. I will show you how to do this in Desmos, and it can actually be done in minimal time. Actually, I'll show that first, and then I'll show the by hand method. So what we can do is we can get the values for A, B, and C by doing a regression and setting the two sides equal to each other. So we tilde this. Should be 5x minus 3. Yep, it is. 1. This has to be a 1. Okay. So it's not correct just yet. What we have to do is define x1 as a list. That way it'll treat the x1 as a variable and not as a constant. There we go. I also have to enter in at least 3 numbers for it to do it correctly. I believe the reason for that is the fact that there are 3 constants, a, b, and c. If I add a 4th one, does it change it? Doesn't look like it. No, you can add a 4th, you can add a 5th. Yeah, it doesn't change it. But you need at least 3. If you don't have at least 3, notice it's all messed up. It doesn't work properly. All right, so now it gives me a, b, and c. Scroll down. What is it? 72. Okay, that is the correct answer to this, by the way. It is correct answer is 72. So that's how you can do this problem entirely in Desmos. Again, I'm using a regression. I'm left side tilde right side. Every x becomes x1, and then I define x1 as a list. I put at least 3 elements in it. A plus b finds a plus b plus c. Okay, now here's how you could actually do this out by hand. It's actually not that bad. I'm going to skip some steps again, just it does take a little while. So first thing, this is going, if you square this out, it's going to be 25x squared minus 40x plus 16. For the other one below it, it's going to be 25x squared minus 30x plus 9. Let me just check my notes. Okay, then if you multiply everything out, I'm just going to do these vertically so they all match up. You've got negative 300x squared. Down here, you've got 150x squared. Negative 150x squared is the overall result. Okay, then you got 480x. Then we've got minus 180x plus 300x. Let me fix that. That is, yes, okay. And then 12 times 16, what do we have here? Negative 192 plus 54, that becomes negative 138. Okay, so if you do this all out, blah, blah, okay, you have this. But now the problem is here, it's got this like a over 6, b over 6, c over 6. So technically that means, a over 6 is equal to negative 150. So you just got to multiply that by 6 and get a to be negative 900. Same thing with b. B is going to be 300 times 6, which is going to be positive 1800. Same thing with c. C is going to be negative 138 times 6. That is going to be negative 828. You add these all together, you get 72. And notice these numbers match the same values I had right here when I did it in Desmos. Negative 900, 1800, negative 828. Okay, add them together, you get 72. So this is how you could do it by hand as well. All right, next question. Here we have a product of roots problem. So we have this equation, and we're told the product of the roots is 77. Find what k is. So, okay, we've got three roots here, three solutions. The first one is going to come from here. It's going to be negative 7 halves. The second one is going to be negative root 2k plus 7, because if you set this equal to 0, you just subtract over the whole square root, and then it's, x equals that negative square root. And the third one's going to be positive 2k plus 7. So these are my three roots or solutions. So I just set this equal to 77. Now, we need to just go ahead and solve this, and we're going to get the value of k. So a couple things. First of all, these two are going to cancel, and you're going to have 2k plus 7 because the square roots are, the expressions on them are identical. Here's a negative, those cancel, it's going to be plus. Then I would multiply by 2, and I would divide by 7. In other words, technically multiplying by 2/7 if you want to think of it that way. And 7 goes into 77 11 times. 11 times 2 is 22. And now you could just do minus 7, 2k equals 15, k equals, all right, let's see here. 15 over 2, 7.5, that's not the value I got initially. Let's check my work and see what I'm missing exactly. Oh, I see what the issue is. Okay, so let's see here. We get not 7 over 5, 15 over by 2, which is, you heard of this, 15 over 2 or 7.5. So that's what k should equal. So either one of these would be acceptable. So let's go through now and double check a couple things. First, if I put the equation here into Desmos, does it give me that as my solution? So I've got negative 7 halves times, I'm just going to use x instead of k. This has a negative in front of it. 2x plus 7. All right. So basically what I'm looking for now is what's the solution to, I need to equal the 77. There we go. All right. 7.5, is that it? Turn here. Okay, it looks correct. I'm going to zoom in. It won't let you click on it, unfortunately, but yeah, you can see right there, it's directly on 7.5. If I graph a line, yeah, it won't let me click on the intersection point, unfortunately. But this just confirms that yes, the correct answer is 7.5. And you could also just confirm that or double check that as well by, let's say, getting rid of this, just replacing this value. Like, I'm going to put k back in, but then I'm just going to add a slider and say, okay, is k 7.5? And it gives me 77. Yes. So correct answer, either 15 over 2 or 7.5, either one. All right, question number 9. We have an equilateral triangle, and we're told that its height is 44. And we're told its perimeter is w root 3, and they want to know what's the value of w. Okay, so equilateral means this is 60, this is 60. Also means these are each 30. Basically it's a 60-degree angle cut in half. So essentially, we have on the left and on the right 2 30, 60, 90 triangles. If you remember your special right triangle formulas, okay, this 44 is the long leg. This 30 is down here is the short leg. So to get from the long leg to the short leg, you technically divide by root 3. In other words, you do 44 over root 3. So this will be 44 divided by root 3. And then that's going to be like, say, this part right here, and it would be the same over here, as well. So one full side, okay, is going to be 2 of these added together. It's going to be 88 root 3. And now for the perimeter, you would, of course, multiply this by 3. So we've got 3 times, and I'm not going to multiply it out, Jez, and I'll show you why, times 88 root 3. Here's the problem, though. The final answer they want the radical in the numerator, not the denominator. So you do root 3 over root 3 to rationalize the denominator. So this and this just becomes 3, okay? You already have the 3 on top. You have the 88 on top, and then now you have the root 3. So notice these cancel out. In other words, the 3 that I introduced because we have 3 sides, that's why I multiplied by 3 here. This is one side, and then, well, we have 3 of them for the perimeter. That cancels out with this 3 in the bottom. So you get this. That means W is going to be 88. So correct answer for this one, 88 is the value of W. Now, if you did not remember the special right triangle formulas, you could still solve this as long as you know how to use basic trig. So what I mean by that is you would say, okay, I know I have this 60-degree angle. Well, you could use either one, I guess. Well, let's use this, 60-degree angle. Tan of 60 equals opposite over adjacent. The adjacent is just the side that, I'm this side right here, okay, in the triangle. So if you rearrange this, you get that side equal to 44 divided by tan 60. So what you'd have to do then is you'd go to Desmos. And I'm just going to define it whatever. It's like capital X. Actually, let me use a different letter just to make sure, because X is a variable. Okay, tan 60, and hold on, I have to just make sure we're in degrees here. Okay, we are now in degrees. So this is the decimal equivalent value of that side, okay? Now, I have to add 2 of those things together to make one full side for a triangle. All right, and notice, since I defined this as this, I can just carry it along for my calculations. So one full side of the triangle is 50.806, blah, blah, whatever. Now I have to multiply this whole thing by 3. So I'm just going to stick a 3 out front here. So this is the total perimeter of the triangle. It's 152, blah, blah. But you're saying, like, well, how do I relate 152.402 to W root 3? Well, this is the total perimeter. This is total perimeter. Just divide both sides by root 3, and then you'll get what the W value is. So now take this, divide it by square root 3, and there we get 88. So this is how you could do the problem using entirely basic trig, not needing the special right triangle formulas. All right, the last question on this first set of 10 problems from the August 2024 Digital SAT Math section gives you an equation, has a constant k in it, and it tells you it only has one real solution, and they want to know the minimum value of 4k. So there's multiple ways you could do this. The traditional way would be to go ahead, square both sides. Left side is just k minus x, square root and squared cancel. Right side, it's 9 minus 6x plus x squared. Technically you FOIL this out, 3 minus x times 3 minus x. Okay, and then first I'm just going to flip the sides. So I'm just going to symmetric property. X squared minus 6x plus 9 equals k minus x. And now we're going to add x, so it's going to be x squared minus 5x, and then plus 9 minus k. All right, and that's equal to 0. So since it tells you it has one real solution, that means the discriminant, i.e. the b squared minus 4ac part of the quadratic formula, has to equal 0. That's what happens when there's one real solution. So we can just go ahead and plug everything in. B squared is going to be negative 5 squared minus 4 times 1 times 9 minus k, and set that equal to 0. And we're going to solve for, technically we're actually going to solve for 4k because that's what they're asking for. And you could say 25, and then here, okay, this is just negative 4. So then distributive property minus 36 plus 4k, negative 11 plus 4k equals 0. 4k equals 11. So the correct answer to this one is 11. Now, an alternate way you could technically do this, I don't know if this is necessarily any easier, it's just this is for the second half of the problem, not the first, is you could go ahead and you could basically, once you get to this step, okay, right here, for this to have one real solution, that means that like basically it factors as like, x plus something or x minus something squared, it's the same factor. Or basically, in other words, you complete the square. So what that means is it's going to be x squared minus 5x plus, and then the number that goes in here if you do completing the square is the b term divided by 2 squared. So it's really 25 over 4. So that means 9 minus k is equal to 25 over 4. So if you go ahead and solve that, k is equal to 9 minus 25 over 4. So, you just go to Desmos. Okay, that's the value of k, and then just multiply that, by 4. 4 times 2.75, it's 11. So you could solve for k and get k equals 2.75, so then 4k is just 4 times that, which is 11. So that's an alternate way to go through it. You can technically do this in Desmos, but the problem is you're solving for k. Here's the approach I would use. I would graph the thing on the left, and you're going to have to add a slider. And then you're going to graph the right side. Okay, and for one real solution, you're looking for where these two curves intersect once, okay, for to have one solution. But the problem is, okay, so right here at 2.8, notice there's two solutions, so it's got to be less than that. Okay, but here at 2.7, you notice that there is one solution, or no solution, excuse me, because they don't intersect. So, okay, if I make this 2.7, the problem is you don't know ahead of time how far you need to zoom in. Sorry, I want this 2.8, I want the step to be 0.1. No, 0.01. Yeah, there we go. Okay. So it's getting closer and closer and closer. It's still, again, zoom in. It's still not touching. There's still no solutions. And then, boom, right there, there's a solution. Why? How do I know? Because there's a gray point highlighted. So you can do this in Desmos, but I don't know that I would recommend it because you don't know exactly how much you have to zoom in on, to get the decimal value for it. All right, so that being said, these were 10 crowdsourced questions from the August 2024 Digital SAT Math section. I hope you enjoyed this video. Check out the videos on part 2 from the August test, which will have 10 more questions, and part 3, which will have 10 more questions beyond that. Or check out my older videos, questions from the June test and or the May test. Otherwise, hope you like this content. Please do give the video a thumbs up, sign up for notifications, and subscribe to my channel. And again, I'll be back here soon with more digital SAT math-related content.